Hey, I'm Emery Stagmer, the executive producer here at Untitled Music. I've done a lot of 3D design recently and 3D printing, and I've got a new project which I've been wanting to do for a while of the Sea Dragon rocket. This is a 1960s design done by a guy named Bob Truax at Aerojet General Corporation. Bob passed away, unfortunately, a couple of years ago. I had done a talk on this at the 2010 Space Up conference, and we're going to put that link right here. Now, for this video is kind of long. I've already shot the vast majority of it, and the 3D design work shows you how to use 123D Designer from Autodesk, a free CAD program that allows you to do pretty nifty 3D models. And I did the whole design as a video, so I shot the whole thing and did myself doing running commentary. And so you're going to get a video here that's about 2 hours long. Now I'm going to break it up into sections. And so here's what we're going to do. The sections that have already passed or that are earlier than the current location that you're watching are going to be over here, kind of to your left and my right. And there'll be links that say you can go back and watch something if you wanted to see something different, or go back and watch something again. The links up here are on my left and your right will be links of things that are coming up. And when we get to those points, those links will move from here to here. So I already have the 3D model printed. I'll talk more about it in a minute. It's really big. I don't even know if I can get it in this camera shot. It's the biggest thing I've ever made. And there's actually a couple more pieces that need to go together on it. These pieces come off. Here's your ballast tank. First stage, second stage. So I'll talk more about that as the video goes on, and there'll be links to the different parts of how I did various things like the cones and the smooth curved shapes, and how some of this solid model construction was done. So here you go. This is 123D Designer. Enjoy. Now, here's actually a copy of what the Sea Dragon rocket looks like, and it's really kind of hard to see here. Let me just drag it over and put it in the screen capture mode, and I will zoom in on this thing. Notice it says station number feet. This command module down here, this command module is the Apollo command module. It's kind of difficult to imagine how big this thing is. 170 feet. So it says water line right here. This thing is actually launched out of the water, out of the ocean. Come down here. There's only one engine bell. This is the outline of the engine bell right here. And there's only one engine bell. This engine bell is 75 down here, 75 feet across. 75 feet. And 536.89 feet. For reference, the Washington Monument in the center of DC, in the mall in DC, is 550 feet tall. So this is almost as tall as the Washington Monument, and it's actually bigger around. So we're going to do a model of both stages. This is stage 1 from here to here, and this is stage 2 from up here, and then this is the payload, this little tiny thing up here. Now, it wasn't really designed to launch the Apollo command module. It's really meant to launch fuel. So in reality, the payload upper section of this would continue straight up from the top of the upper tank and would have a payload of 1.1 million pounds to low Earth orbit. It's crazy. But we could launch the International Space Station in one launch. Okay. Von Braun's torus-shaped space station, the big hub from the 2001: A Space Odyssey. I think it's 3 launches. I think we figured out. So it's really, really crazy. All right, let's get this back over here. I'm using this as a reference on my other screen. So this is 123D Designer. So I'm going to zoom in on these other sections in here so I can figure out how big some of this stuff is. But basically we're going to start with a cylinder that is the first stage cylinder itself, and that system goes from, where's the cylinder start? About 350 feet to 434 feet. Now I'm going to use 1 millimeter to the foot. I don't know whether I can actually print that or not. Probably can't. No, I probably can. I may have to scale it to print it on my I have a Leapfrog creator at work. I may actually be able to try and print it on that. All right. So over here in 123 Designer, insert a cylinder. We're going to put it right on the center of the origin. Its radius is going to be 75, and its height is going to be 434.76 minus, where's that stage start? See if it gives me an actual point. Oops. I just don't want the center of the thing to be at the center of the environment. Minus 300 minus 150. Oh, you just let me do that. Huh, 434 minus 350. Did they really take that functionality away? Oh, that's a darn nuisance. All right, shoot, maybe do math in my head. 84 feet. That can't be right. $75 feet in diameter. 434. 350. Radius. It's a 37.5 radius. Proportion looks better. Helps if you remember it's radius and not diameter. The upper stage is from it's like about 105 feet to, what did that one start? 350? 105 to 350. It's 145. So this cylinder is going to go centered on that cylinder, 37.5 and 145 feet. Does that look right? Yeah, that's not bad. Okay. Right. Let's pull this back over here. So what you're seeing here is this is the first stage cylinder, and this is the second stage cylinder up to here. Those proportions look about right. Now I need a cone on the top. It's going to be frustrumed a little bit. 37.5 and a height of, get back over here. Cone's going to run from 42 feet to 105 feet. 42 to 105, 60, 30. Now that cone's actually going to get cut off because the top section is... I wonder what the diameter of the command module is. See if I have it in the picture. That's stage 1. So this is the stage 1, what stage 1 looks like. This nose actually is reinforced to splash down in the Atlantic Ocean. So I'd have to go look up real quick what the command module diameter was. Honestly, let's see. I think I want to guess. So we're going to guess that that was 15 feet in diameter. Can I put a cylinder directly up on top? No, it wants to make it... Okay, so let's do this. Sketch a rectangle. Doesn't matter where, right here. We're going to take this rectangle and we're going to move it up by I said it started 42 feet. 42 minus, darn, this thing's big. 42 minus 434, 392 millimeters. 392 millimeters. Obviously I did something wrong there. So let's measure it. What's the measure of that ring to that ring? Those results are 145. And that ring to that ring is 229. Clear that. What's this point? Need to point to that ring. It says that it is 229. $145. 84. It's not 145. It is. Close this. Move that. Move it that way. 100 millimeters. Because I made this too short by quite a bit. So I need to make it taller. So what I'm going to do is I'm going to grab that face, press pull that. I think I missed by 100. It only let me do it in plane. That's kind of interesting. Not what I had in mind. What I'm going to do is I'm going to move it up here. 100 millimeters. Actually, let's move it back where it was. All right, let's redo that. undo this, move vertically by 100, and move laterally by -100. Just put it right back on top, and now, oh, look at that, everything is right where it should be. Scale, non-uniform, XY, 1.2. So the only thing I wish a bit would do is scale it from a base point rather than scale it up and down. I'm better off at this point drilling a new cylinder. Delete. I mean a new cone. Oh, I'm sorry. 37.5 and a height of 42 feet. We go through and do the math again. It goes from 42 to 105. So it's 63 tall. Right, okay, so that puts that plane right here. Let's move this down. What I'm going to use, I'm going to use this plane to cut that cone. At about the right location. I'm going to kind of guess. Alright, so now I'm going to use this plane to split. Alright, so we have this sketch plane. This is where we want to cut this cone. Now, the easiest way to cut this cone is to make another cylinder and then cut the cone by the cylinder, but I need that cylinder to start at this plane. So if I have a cylinder, I can actually put it on this sketch plane. See, it kind of won't let me do that, and it won't let me put this cylinder up here. So what I really need to do is create a cylinder that's right at the sketch plane. So I want to take this, and I want to say then, project that onto this sketch plane. Alright, now I have a cylinder. Alright, now I have a circle, a sketch circle. So I'm going to extrude that sketch circle up, and it automatically deletes it, and I can get rid of the sketch plane. Alright, so now I want, as you can see, let's see here, give me that. As you can see here, I have a short cylinder before I actually have the nose cone. So I'm going to need to know what the diameter of that circle is. So let's measure that. It is 4762 in radius. Let's see. Copy to clipboard. Let me do it. Come on. Select all. Copy. Okay. Close that. Cylinder right here on the top center. Put it in the middle. 4.762. And a height of, I'm going to actually just take the default height, and then I'm going to guess, because what I'm going to do is I'm just going to make this look pretty good. Press pull this, move it down. It's going to be about, I'm looking at the picture, about like that. Alright, and then we're going to need another cone on top of this. Cone right here, 4.762, same diameter, and a height of 10, 8, shorten that, 6, and that's about right. Alright, we don't even have the rocket motor on the first stage yet. Okay, and so this is approximately what it's going to look like. I'm going to go ahead and save a copy of this to my computer. Now that I've gotten pretty close to this, let's see, go up 1, go to C Dragon, go down, C Dragon 1. All right. So the next thing I'm going to need is I'm going to need the engine bell. Just a sketch of that engine bell. Again, here's the picture, the diagrammatic picture of the Sea Dragon. And so far we're down to this point right here. So I need to do this section and then this section. This stuff on the outside is a ballast frame. That's this frame here. It's not actually part of the rocket. We will model it. We'll do it separately, so that that can be printed separately and added to the model in case you wanted to, I don't know, float it in your bathtub or something. So I'm going to do this as a guessy sketch. I'm going to do just basically 2 cones. This really should be curved. At the scale I'm going to print it, I don't know that you could even see the curve. So for something like a 3D print, not too worried about it. I may go back and refine it later, make a curve out of it. I can make a curve out of it now and revolve it around the center line. And maybe I'll do that. All right. In that case, I'm going to need a line. But to get a line so that I can revolve something around about the center of this, what I'm going to need is I'm going to need a line. I need an object I can revolve it around. All right. And to do that, I'm going to need a line. So to get a line, what I've got to be able to do is draw vertically from the center of this thing. In order to do that, the easiest way I know how to do that is to go ahead and put a box in the middle of this. And then my center's not actually centered. This thing is 20 by 20 by 20, so this is a standard size default box, and it's in the middle of the cylinder. What I'm going to do is I'm going to move it so that its vertex is in the middle of the cylinder. Alright, so now I have that vertex is actually in the middle of the cylinder. The whole thing is not actually in the center of the 0 to 0 sketch. And I'm going to draw a line from there, first point here, second point here. Done. Okay. Now I'm going to delete that. Now I'm going to delete this because I don't really need it anymore. I ended up with 2 lines inadvertently. I don't need the second one. I just need that middle. Alright, so then let's do we need to do a sketch. Again, I'm going to need a different... Alright, so let's put it out here. That sketch is going to actually come... Where's the plane of that thing? Let's move this out to here. Can I move it out to the edge? I don't know how wide this is. So let's move it this way. Let's move it back to where that thing was before. 10 that way, 10 this way, and then we're going to move it to the left, minus 37.5. So now the edges should line up right on this edge. Alright, that's good. Now, that thing needs to be a lot taller than that. I just need a surface for the sketch. I just needed to know what surface it was on, so I needed something that was right on the edge of this cylinder. And it needs to be in this face. So we're going to do a spline this is the face. Now I'm going to kind of wag this a little bit. First point here. And it's going to flare out pretty quick. Let's get in where we can see what we're doing here. I want it to be able to flare out like that. Flare back in here. Comes around like that. And out to here. Oh, I should have hit enter, not escape. I'm going to go see how tall its engine bell is. Let's just put another couple control points in the spline. Alright, delete the bugs. Now, what I really need to know is how tall these things really are. So again, back to the design. This goes from 434 to 536. So this thing's 100 feet tall. Holy smoke. All right. That means that this needs to be 100 centimeters. Can I measure the distances from here to here? How long is that? It's only 41. It needs to be twice that big. The engine flares out. This needs to look more like that. This comes in here a little farther. This comes down. I'm just screwing with the splines here a little bit. What's that look like here to here? Close. That's 80. Starting to look a little more like it. All I really did here was give myself enough control points that I could go screw with it. Alright, 80, so it needs to be basically down here. Now, I can't. Now, see, it can't go that far out. So the whole thing actually needs to come in a bit. Perspective was screwing me up a little bit there. You can do an orthographic view here too. Where are we now? Oh, 100 millimeters. That's pretty cool. I still think that shape's not quite right. This needs to come in, and this needs to come in. That started looking like it. Yeah, that looks pretty good. All right, let's take this spline and revolve it. Revolve. This has to be closed. Silly me. All right, so I need to have made a closed path here and not just a curve. That curve's not going to do me any good as it is. All right, so it's got to be a closed face. Get out of that mode. So what I need to do is I need to make a polyline from whoops, grabbed the wrong mouse control. We're going to hollow this out anyhow, so it doesn't matter if this bottom is exactly parallel. Now I've made a solid. Okay. Now I can take this whole thing and revolve it. That's what I want to do. Take this face and go on the widget, revolve it about profile that against that 360. And you won't do it Y. Axis is new solid 360. And there we have our engine bell. That's not too bad. That's not too bad at all. And it looks a bit like a rocket. Again, I'm guessing on the engine bell shape exactly, but it's not too bad. Now the thing is, it should be hollow, of course, right? So I want to take this shape and I want to then shell it out. Shell. Put this inside. Huh. Doesn't know how to do that, huh? That's interesting. Well, sometimes the limitations of this package are kind of interesting. Let's do this. Radius 35. Yep. Height 80. We're going to take this thing and we're going to rotate it 180 degrees. We're going to take the whole thing and we're going to move it up by... I don't want to go all the way up to 80, even though it's 80 tall. Let's just go to 79.5. And then let's do this. Merge, subtract that minus this. I was curious. Move this up by 79. Must have had it rotated not exactly 180. Subtract the large minus the small. There we go. Now we have an interior engine bell, at least a couple millimeters thick. Now we're getting somewhere. All right. Now at some point I'm also going to go back and if I take these three things and I group them together, all right, now I can move that whole thing up. So it's, I need to remember how much I moved it. All right, let's move it by 100. That way I know where it is. So one of the other features of this crazy system is that the first stage, in order to have more tankage, didn't cut off straight. It was actually pointed. And you can see that here. See this point right here? This point is part of the tankage of the first stage. This is the engine bell for the second stage. Okay? So the first stage actually goes up inside the second stage in order to increase the tankage and shorten the overall rocket. Otherwise it would have been 700 feet tall or something crazy. It's pointed kind of like the first stage is also pointed. So I'm going to need to add a cone to the top of this. That represents the first stage. 37.5. And how tall is it? Jeez, I don't know. Let's say it's 40 tall. Looks about right. To go back and figure it out. Now I'm going to take these things and I'm going to group them together. Okay. Let's move him back down. That's 100. Let's make a copy of this, because I'm going to use him to subtract this stage from that stage, and I want to make sure I don't lose it. So I'm going to copy it and paste it, and then it automatically gives me a move dialog. So I'm going to move it over 100. Right, and then I'm going to use a subtraction. Subtract this minus that. Now, I'm just going to leave the sketch. Now there's a cone in there. It's hard to see. Move that back by minus 100. So there's the basis of that. Now the next thing I want to do is I want to do the vernier engines. These are these control engines that sit out on the outside. The TVC, thrust vector control, TVC engines. All right, and so let's see if we can figure out what the heights of these things are. 270, 280, 290. So they started about 283 and go to 320. 283, 320. So they're about 37. 37 tall, and we'll have to figure out that angle. That's a, I don't know what that shape is. Let's see here. See if I can see it on one of the other sketches. Looks like they are so it looks like they are squares. So I need a box. We're just going to stick it down here somewhere. Well, I'm going to stick it on the side of the rocket. They're going to be I'm just going to stick it down here on this face. I thought they were 37. Length. So the height is 37. We're going to guess 20 by 20. Man, these things are really huge. How about a 20 by 20 foot box just for the thrust vector control engines? That box is this size. I mean, 20 by 20 is a very large room. These things are huge. All right, I'm going to need 4 of these, so I'm going to make a copy of this one and just use the other one. But I'm really going to be just moving these guys kind of approximately where I want them. Now, they also have to rotate 45 degrees that way, and alright, so they got to be taller than that in order to. Oh, that's better. The reason I keep going back to move is because the axes will stay aligned with the object until you disconnect and reconnect them. Alright. So then I need to make this hollow. Shell that out and make the inside thickness yeah, that's pretty cool. So now I need to find out, where did I put this? I need the capsule to the edge of that. And that distance is 209. That's to the bottom. Let's see, what was that number? 310. The 209 is 40 feet off the top, off the point of the escape tower, because that's the base of the cylinder of the command module. So this is currently at 209 plus 40, roughly 250, needs to come down. Really? Yeah, it needs to come down about 60. All right. So this needs to move down minus 60. Yep, that looks pretty good. Actually, even that's probably a little high. Here's what I'm looking at, is the distance from the bottom of that to the top of the first stage. That distance right there, and that looks to be a little too far from here to there. So I'm going to say I need to move it down another 10 feet. Yeah, that looks darn good. All right. Take that. Let's make a pattern of these. Circular pattern. That's solid. About. I still have this axis down here somewhere. No. Circular pattern, that object. Axis. That axis. Oh, how many? 4. That's starting to look like a rocket. Save that. All right. All right, more later. So I left off with the Sea Dragon right about here. I colored it a little bit since I finished that, but that's all I did is apply materials. The next big trick is that I'm gonna do this section. Now, the engine bell comes all the way down to here. This is a ballast system down here, and as you can see, maybe here, this system comes all the way up inside the engine bell. So I'm going to make this as a separate unit, and it's got what I'm guessing are 4 supports here that go from hinged right here on the ballast tank and connect up here into the system. Let's see if the other picture is any clearer on that. Pull it over here. Yeah, so you got these down here, and I'm not sure what these sections are there. This appears to be a cutaway portion of that. Might have to go in and actually look at the drawings here. But what I want to make right now is this section here with this ring and these ballast tanks. This ring, I think that the nozzle continues down. Let's see here if I can look at both of these. If you hear outside, my daughter's got a bunch of friends over. Yeah, the engine continues further down here. This kind of covers it. So this engine continues down inside of here, I think. Might have that engine bell a little too long. Let's get rid of these guys and go back to the model. All right. Yeah, so that pull that back over. Yeah, it looks to me like that engine bell is probably too long. It should probably cut off about here. Let's see if we can figure out a height from this drawing. So the engine bell starts at about 440 and runs down to, no, about 540. So my whole engine bell section here is about exactly that same height. I probably need that flare to be slower just to make the curve right, but I'm probably not going to change it. So I got the height right. Okay, that's good. The next thing is, of course, to try and figure out what to do with this section. So you've got a skirted section here, which is actually round. Oh, come here. Let's see if we can look at that at the same time here. So that rounded, so that section, this section here is actually this segmented section here. It's just shown as a segment. We'll make it a whole cylinder. And then there's supports that come up. These supports will come up from the bottom of the engine bell all the way up, kind of where this profile, looks like it runs to a certain extent, right? So it'll be kind of cool. Let's see. That thing is the bottom of the engine bell at 536. It runs down to about 570. So let's call it 40 feet tall. I think it's 4 stories tall. That's a big ballast tank. There's nothing about this rocket that's small, but wow. And then these arms are like 100 feet long. I mean, they run from 434 to 536, so they're 102 feet long and angled in slightly. It does tell me that the engine bell is actually slightly wider than the outside diameter of the rocket body, which mine is about the same size here. So I could actually flare mine out a little bit more and get rid of some of this curve and make that a little flatter, which it probably should be anyway, right? But somehow I have gotten this cylinder and this curved section somehow I have gotten them combined, and I really didn't want to do that. But if I'm going to delete it, invalid operation, and redo the curve, anyhow, it kind of doesn't matter. All right, now I need to know, I'm going to measure here from this that face to this edge, and the measurement system tells me that's 84 millimeters. Cancel. 84 millimeters. So I need a cylinder that is tied to the bottom of the center of this. That's a radius of 37.5. Come on, grab this system here. 37.5 and 83 tall. Okay. All right, that's good. And then I want to change this curve a little bit. Pulling this line out. Gives me a better profile. Alright, so let's take, I wonder if I still have the center line in here. Probably. Take this, revolve it about. And there's the axis selected up here around this axis, 360. And make it a new solid. Okay. These two should be separate objects now. They All right, that's good. All right. So the one thing about this is it means that I don't have a hollow cone. Try something fancy. Let's take this whole thing. Can we copy and paste that? Yes, we can. So let's see. Hide none. Do that. Show sketches. All right, let's take this whole thing, copy and paste, move it this way, minus 100, just so it's convenient. I know it's 100 away, right? So then I'm going to take this whole thing and I'm going to scale it non-uniform. This way I'm going to scale it factor of 1, let's see. 0.9. Now, if I copy this, move this back, move this back 100. Did it change? Oh, it didn't really do what I wanted. It's kind of weird. Let's just draw another curve here. Spline in this face. And we're just going to make this this is largely going to be a solid, so click to specify the first point. I'm going to click in here. I'm going to click in here. We're going to follow this contour. This doesn't matter because I'm going to basically use this to delete this anyway. Alright, so that makes that a solid. Let's take this and monkey with this curve a little. Change that curve. So let's take this region. Here's what I'm trying to do. Take this region and revolve it about this axis. 360. No, it didn't like that. Revolve about this axis. Now I have the same outside profile, but I have a nice smooth inside profile. As I subtracted the one, basically I subtracted the one from the other. Alright. That I like. All right, let's select all this stuff, and well, let's just say go over here, hide sketches. So you still have the sketches. Nice smooth engine bell on the inside. That's pretty cool. 3D printer should be able to handle it pretty well with basically not really any supports. Maybe it'll want to do some supports right in the middle. But if I had some hangers in there, it wouldn't be a big deal. All right. So I'm way happier with that engine. All right. I've saved this as version number 2 of the file. I made a copy of the original before I started monkeying with this. And these are still separate objects, which is good. I don't know why they get combined before. Some way, it's the way I did the subtraction before. I think, I don't know, did something funny to it. All right, so let's try and make some ballast tanks here. Now, I said these ballast tanks are 40 feet tall, and again, if we look at the shape, they're kind of 2 spheres with a cylinder in between. That's something that this program does really, really well. So let's say I'm going to have that. How big around are they? There's a real question, right? Does this drawing have any measurements down here? No. Well, this is the drawing for the propulsion system. Let me find the other one here. We're going to end up having to infer those sizes. This is 100. Well, we know what this is. It's a little better than 75, right? What's the outside diameter of this? Make sure I'm getting the right, correct ring here. It tells me my radius is 43.291. So that radius needs to be 44. So that's 88 in diameter times pi, and that'll give me a circumference. And then if we go back and look at this drawing, the outside of the circumference is going to be where these things go. We can kind of infer this from this distance. I'm using my fingers here. You can't really see what I'm doing. I'm using my fingers, and it's about, let's see, where's the 500 mark? They're about 25 feet in diameter. 25 feet in diameter and 40 feet tall. It's big as a house laying on its side. So if they're 25 feet in diameter, 12 and a half feet in radius. So let's make some, let's try and make a module here. Pick a sphere. Let's just put it in the center. Radius is 25, 20, 12.5 feet in radius. And then copy this up. Paste. And 12 and a half is 25, and I want them 40, so the difference should be 15. All right, so that looks about right. And then I want a cylinder to go in between them. The cylinder should be 12.5 by 15. Oop, not quite lined up. That looks pretty good. So it's not quite lined up the way I wanted it. Move up by 12.5. All right. Move it over. Move it back forward. Ah, that's more the thing. How does that look shape-wise compared to these guys? That's pretty good. All right. I'm going to group these guys. I'm actually going to merge these together. Combine, merge that, this, and this. Okay. All right, now I have a pill. All right. So let's move this guy. Now he needs to move down to just so the outside of this rocket motor assembly. Move. Kind of guessing on the move here. Doing on the alignment here. Ain't bad. All right, let's. What's it need to look like? Outside, just a hair. All right, not bad. Let's show the sketches again because I'm going to hide these guys. I want that line. Well, that line, I don't know, that line ended up not being in the center somehow. Oh, maybe he is. Is this rocket still really in the center? No. All right. Let's see if we can do this. Now, circular pattern. That's solid. This axis, 6 copies. Hey, that's all right. Save. Okay. That's pretty neat. So the next thing I need is this thing actually has a skirt here that's about 30 feet tall. So I need a cylinder. Again, we're just going to have to move this to pretty much where we want it later. Now we figured out that that was 44 in radius and right? Nah, yeah, no, it's 43. Yeah, that's right. So then the height was 30. Okay. Now we're going to make this a hollow shell. What I'm going to do is take another cylinder, put it in the top center, make it 43. 1 millimeter thick. Nah, it needs to be more like 3 millimeters thick, just so it'll print.
40, 41, and we're going to make it 40 tall. It's hard to print anything under about 2 millimeters thick as any kind of a shell that's going to be of any substance. So I made just 3 millimeters thick, which is, all right. Move this down. Move it down one more. Okay. And then I'm going to subtract this minus that. And end up with this ring. And I'm going to take the ring and I'm going to move the ring down. Looks like I almost got that lined up. So now you'll notice that these guys are sitting on the outside of that ring and they need to sit on the inside of the ring. So 1, 2, 3, 4, 5. You go away. Probably should have done the ring first, huh? Alright, let's move this guy in just a little bit. Move him in. Let's say minus 7. That should be just inside. It's not actually touching. There's actually a support structure that's going to have to go along the bottom of this. I don't know what this center represents. This may be where the plug attaches. Plug's not shown in this diagram. These actually look like they intersect this outside wall. It'll print better that way. So let's move this guy back out 1 millimeter. 1. So he actually intersects that wall. Sorry, just reorienting the model here. I want to see that he's sticking out just a little bit like that. Okay. Now then, I'm going to recircularize him, make a new circular pattern. This guy, now I want this whole solid axis. Come on, give me the axis, you silly program. Somehow it didn't select a solid correctly. It selected an aspect of the solid. There we go. Select the whole solid axis. That axis. There we go. 6. Okay. Now we're getting somewhere. I've left these. Now they got a gap in between them. That's okay. These are actually going to be printed as separate objects anyway, so we're going to leave them solid, separate for now. They all intersect the shell nicely. That's good. Now I'm going to need a what do you think? What's the cross section here? Square, round, cylinders? Yeah, look there. I'm going with cylinders. These are cylindrical, and there's a there's something on the bottom of each one. I'm just going to go with a cylinder here. All right. The camera movement on my face, by the way, is totally being done by a face recognition algorithm in the Logitech webcam software. So if it's doing something goofy, I'm not actually controlling that. All right, make a cylinder. I don't know if I can do this easily. The diameter is going to be really small on this, maybe 3. Yeah. wish it would give me a nice way to do a nice vertical cylinder on the top of this. Let's measure the distance between these first. Here to here. I don't know what kind of distance it's giving me. 4 millimeters, which is obviously just the edges between them. That's not what I want. I have to guess. We'll just push-pull a cylinder. Let's do that here. Okay, so we're just going to make a cylinder. We're going to put it right on the edge of this thing. We're going to make its radius 3. We're going to make its height. We'll just leave it at default. All right, so we're going to take this thing and we're going to first off, we're going to rotate it 90 degrees this way. Right, and then we're going to rotate it by 30 degrees that way. It looks pretty parallel. We're then going to move him it's giving me a weird angle control here. So we're working upside down here, so it's a little bit funny. It's pretty well lined up. It's a little bit short. So we're going to grab this face and press pull that face out until it matches. Yep, a little bit more. That object, that face. Grab that thing, press pull. Let's get over here so we're looking at it on 90s. Right there, that's pretty good. And then we're going to do the same thing down here. This object, that face. Grab that thing, press pull. Let's go back to looking at it edge on. And bad. We're gonna make that thing smaller. This was 3 millimeters in. Oh, that's a radius. Oh, I can go down a lot more. 1. So that's 2 millimeters in radius. 1.5. That's closer. All right. Move this down until it touches. That's pretty good. Let's see what happens if we make a circular pattern out of these. Take that object and this axis. Invalid operation. Why? Circular pattern. That's solid. Axis. That axis. Oh, it's giving me invalid pattern for some reason. Looks like the solid is okay. It doesn't like the axis. There we go. 5, 5, 6. cool. All right. That'd be an interesting thing to try and 3D print. There's some strange ways that you're gonna have to. I'm gonna have to run supports underneath of that, print it upside down or something. I'm happy with that. Let's save that. How about it, Bob? How am I doing? Need the outside supports. In the reproduction PDF, which you can see here, there's a really bad reproduction of a pencil sketch of the Sea Dragon essentially floating out to sea with a aircraft carrier. I wish there was a good copy of this pencil sketch. I wonder if Scott Truax has one. He's on Bob's son Scott is on Facebook, so I may need to try and follow it up. Maybe it looks like this. Maybe I was wrong about this. I don't know. It's a crazy cool picture. I wish there was a really good copy of it someplace. There's no apparent signature of this thing. Who did it? Probably somebody at Aerojet General who's been dead for 30 years. I don't know if Bob had left a good copy. All right, we're going to continue. See, they don't show the ring around here, but this other picture seems to. Maybe not. Well, what's this ring? See, that ring doesn't show up in this picture. This ring doesn't show up in this picture here. It would be right in this area here, but it's not. Let's get rid of that. Go back to here. I'm sticking with the ring because it's closer to this mechanical drawing than anything. Guess I could. Well, that's all right. We're gonna stick with this. That looks pretty close to that. I'm gonna have to, even though my my Leapfrog Creator is 200 millimeters tall, I'm still gonna have to print this thing in 3 pieces. It's gonna be like, well, it's gonna be almost 500 millimeters tall, so 50 centimeters. It's pretty big. All right, next is those arms. Those are just boxes, really. All right, so we're going to make a box that's on the outside of this, lined up right there, whose length is 3 by 3, and height. Oh, it's got the height. It's got a funny height. How tall is this thing? It's 100 and. Well, it goes down to the top of the engine bell, so it's 100. All right. Take this thing and move. Move includes, you know, rotate and stuff. All right, let's make it 90, and then let's just drag it. Yeah. You can drag move things in here, but in my humble opinion, it doesn't work very well. It's never obvious in which direction you're dragging things. See, it's sticking up just slightly above here, which probably is okay. Right, and that's going to be a couple degrees in, which is correct. So one of the things I want to do is I want to make sure that it is, this thing is centered on this little grid line right here. But that point is not, so let's move him over by, he probably needs to move over in the half millimeter range. Yeah, minus. So let's do this. Let's grab this face. He needs to be a little bit taller. Press pull this, pull it up a couple of millimeters. Yeah, it attaches to something on the outside of the rocket, which I'm not going to bother to model. And again, this is a little bit short. Grab this face. And press pull this, pull it down about here. Okay. Circular pattern. Grab that solid. Get down here so we can see this axis. Looks pretty darn close. All right. There's pairs of them. How are these veins constructed? What do you think? I think those are solids. Is this a cross section? This thing stays in the water. This part down here, this whole section down here stays in the water. So these actually aren't, these right here aren't hinges, they're releases. So this releases this whole, these things kind of flap down like this, and the whole bottom section stays in the water. This whole ballast stays in the water. It's this thing that keeps it afloat. When the rocket lights off, this goes down and then comes back up to the surface. The water line, by the way, is way the heck up here. Here's the water line. I don't know if you can see in that. There it is right there. So the water line is like, where'd it go? There's the water line right there. So here's the thrust vector controls, and here's the water line. So the water line is probably in this region here. So from here, like from here down, is all in the, it's all in the water when the thing lights off. All right. It's pretty close. So the last thing I did was change those around. All right, so the deal is these need to be a pair. Now, if I rotate this, unfortunately, if I rotate this, it's going to rotate about its center. So then I'll have to realign it. Here, see what I mean? Well, I grabbed the wrong control. Move. Grab that. Now I want to grab. Yeah, I want to grab that control. What do you think here? 10 degrees? I'm wagging this one. Copy, paste. 20 degrees. And then move that back over here until these intersect. Of course, now neither of them touch the end here. That and that. Move both of these by rotating them this way. 1 degree. And then moving them in by minus 1 millimeter. Minus 1.5. It's not rocket science, eh? That's weird. I'd have thought those would have lined up better. All right, move those over. And 2 and down. All right, how's that? Looks good down here. Something not even. Oh, there's the problem. Why don't these look right when they're lined up on that grid line? Because see that this ring is thinner here than it is over here. This whole section is off by a millimeter or 2. All right, let's grab all of this. 2, 3, 4, 3, 5, 6. 1, 2, 4, 5, 6. Move all of that to the right by 1, not even that much, 0.5. All right. What does that do to this? All right, let's move him here, and him, move him back over. I would swear that's lined up. I don't know what I do here. going to rotate that by 1 more degree. And this axis, 1. And tweaking back over. 1.5. That's as close as I care to bother to get. Alright. I'm going to take these two, I'm going to merge them together. That one and this one. Alright, so they're now one object. Alright. Take this object, make a circular pattern about that axis. 4. Alright, that looks good. Alright, so I also am going to need a triangle. I'm going to use something interesting here. We're going to use the loft. So I need a couple of triangles drawn in the spaces. To do that, I'm going to make myself I need a reference plane in which to be able to draw this sketches. So that box is just a reference. I'm just going to use this face of the reference plane as a reference plane in order to draw things. Where do they need to be drawn? Doesn't really matter. It's got to come. See, it's not going to come all the way down. It's going to come most of the way down. And those things weren't perpendicular to that either. They're about a almost 45-degree angle. So rotate this by 45. This is again just a sketch plane. All right, draw let's draw a polygon on that sketch plane. Center of the polygon should be right here, and I want 3 sides. That's the center. That'll do. Excellent. Okay, that's pretty cool. Let's just go ahead and hide this guy for a moment. All right, I need to scale this. And then I'm going to need to move him. Move the whole thing. Move. It's not bad. That's kind of cool. It's the first time I've tried to do exactly that, so it's kind of neat. Scale him down till he's going to fit. Move this guy then down to... -0.5. scale him by some really small, then a really small triangle. Right, so he now needs to move until he intersects this thing. And now we're going to use the loft. New solid. Him. 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 Hide this for the moment so we can see what we're trying to do here. Loft. That. That. Do I have to have 3? Maybe I have to have 3. Show solids. So we definitely don't need. All right. That to there. Ah, that was my problem. It was selecting the edges and not the face, because I was zoomed out too far and it just kind of didn't know what to do with it. See, there's the whole face, and there's the whole face. That's what we really wanted. And we don't need this guy at all. All right. Show solids. All right, so that little triangle isn't lined up quite right. You need to be hidden. But you're not letting me get to this guy. You also need to be hidden. You need to move that way. Cool, that worked pretty well. All right. He needs to move. Just trying a 0.5 millimeter. I didn't finish the operation. Oops. Hit enter. Let me go back to the solids. Okay. I don't know what those things are really intended to be, so okay. Merge this together. All right, now I want solid objects. Now then, make a circular pattern out of that. Axis, that axis. See, I still haven't finished the operation, right? So they're still kind of here. And I can turn individual ones off if I wanted to. I think I'm going to pretty much call that done. I'm going to end up printing these guys probably as separate objects. And then print the bottom section here upside down as one object. The nose cones separately. So, I'm sorry, not the nose cone. Rocket bell separately. This is just a cylinder. Well, no, he's more than just a cylinder, right? He's a cylinder with a he's actually got a cone on the top. But I'm gonna have to break this in half in order to print it. Not entirely unlike, this is a Falcon 9 rocket, and so it had to get printed in 4 pieces. Actually, it'll be almost as tall as this thing when I print it, although this is not the same scale, obviously. If this was the same scale as the Sea Dragon, this nose couldn't be about that big. So, all right, next section will be actually doing 3D printing.
So here we are at the end of this video. Kudos to anybody who actually watched the whole thing. There's a lot there. You can see right here, this is me editing the section that you just watched, which may be a little bit surreal, but I actually got that working. So here's the 3D printed model. We'll start with the bottom. This is the underwater ballast. And I've cleaned it up a little bit. You can see it was printed. This had to be printed with supports. I cleaned it up a little bit. I haven't really finished really cleaning it up. But the way that these I guess these are tanks. The way these tanks printed out came out really great around the top, and the support hexagonal support system around the bottom came out really neat. This printed as one unit. I deliberately made sure that these tank-shaped objects were embedded essentially in this outer cylinder so that it would all print as one integral object. So that's pretty cool. That printed like this, and I printed at the same time. I printed those those triangular support pieces. These came out pretty neat. And I have yet to, these have to get glued onto here like this. And they attach, the top of them attaches to the cylinder of the first stage. So here's the first stage. Here's your a big engine bell. This thing is about 75 feet in diameter, and it's as tall as a 10-story building. Okay, this section is a little bit taller than that. So the ballast tank goes on the bottom as this sits in the water, and this section would be completely underwater. The water line's like here, and then these sections, these support pieces, attach down to here. I assume that in the real thing that they'll attach with hinges, really big hinges. Again, this thing's as tall as a 10-story building. Really big hinges, and the top probably detaches explosive bolts or something. So once that rocket motor really lights, you detach this, the whole tank comes off, and the thing lifts off out of the water. So these have to get glued on here. I may actually make small support pieces or something that I can use to glue those pieces on the bottom. I'm not going to leave them, or I'm going to leave them unattached to the first stage, so they'll sit approximately like this. I'll somehow make it so that you can take the first stage out, just because, why not, right? And so you can see there's a seam right here. I actually ran out of filament on the spool that I was printing on, because I was printing the engine bell and the top part side by side, sitting on the 3D printer. And so when I ran out of plastic, what I did was I measured that height, resliced the model, took that part, put it down on the ground, take the top part of this. Again, you can see the seam here, and printed the nose cone here as two separate pieces, and then just glued it all together. Just gel super glue works really good on the ABS plastic. I don't know if you can tell in here. You can see in here there is the hexagonal pattern of the 10% of the fill pattern, and because I knew that the top of this curve wouldn't print on the 3D printer really well, since I had it apart anyhow, I actually printed it upside down. So this section printed this way, and then this top part right in here, I actually flipped it over 180 degrees and stuck it down, and that printed real clean. So that way I didn't have any supports inside of here, and I printed this the same way. So here's stage 2. You can remember how big these things are. These are 20 feet across and 40 feet tall. These are, and they're rocket, usually, I mean, in reality, there were rocket motors up inside of here, and it would, so that would, if that motor fired, it would push the rocket over this way, or probably push it that way, right? So it would push it up, so they would fire these motors, and they would throttle them up and down in order to control how the rocket was flying. So these were printed as two separate pieces again, and I printed this one upside down. So this printed the top half printed this way, and the bottom half printed over, so that the cone in the bottom, I didn't have to worry about any supports, and these pieces printed with no support. So this is all printed really, really clean. This came out great. I think I made these a millimeter thick, just so that it would print clean. And then again, I glued it together. So I'm going to actually sand and paint this. That's my goal, to paint it in the black and white that we see in the pencil sketches that are in the design. So altogether, this is a very, very large 3D printed model, and I'm going to eventually have it in my office at work. Thanks a lot for watching. I hope you learned something. Please leave me comments, and follow me on Twitter at VaxHeadroom. Thanks.